Hello AP Electricity Magnetism students. Welcome back to my basement. So I just recorded the balloon lab which you watched over a week ago, but while my basement is nice and dry from the dehumidifier running and working so hard, I'm going to continue on with this experiment, the electrostatic charge experiment. So at this point you should have printed these sheets out here. We're going to go through, fill these in, and practice our understanding of charge and the charging processes as seen in the PowerPoint presentation that we just worked through together. So what I have here, first of all, is my rusty table that I use in my garage. I've covered it with white paper so that you could see the object of our experiment, pith balls, P-I-T-H, hanging on threads. And so we're going to do some experiments with them. And I also have a piece of plastic. This may look like glass, but if I hit it on the floor, you see it's plastic. It's a clear plastic rod. And the fur that I used in the balloon charge experiment. And I didn't tell you in the balloon charge experiment, but this is actual real fur from an animal, from a rabbit actually. And no, I didn't kill and skin the rabbit myself. You buy these from science physics catalogs for just this purpose, to do charging experiments. So it turns out that the fur and the plastic have different strengths at which they pull electrons into their molecules. And the plastic has a stronger affinity for the electrons than the fur. So when I rub these two together, what will happen is there'll be charging that occurs. And I don't know if you'll hear it, but, well, I can't really hear the sparking, but, oh, wait a minute, there we go. So you hear that. So that is what we did in part one. So it says, the teacher charges up the the plastic rod by rubbing it with fur. It then exhibits charge effects. So what you have to do is draw some electron-proton partners in both of these before. And before I rub them, like everything in nature, it's made of charges, right? Me, the table, these pith balls, because we're made of protons and electrons. But usually we have equal amounts of protons and electrons, and that means we're neutral. So in this diagram, you could draw 3 pairs of protons and electrons on each object. And then when I rubbed them together, I said this had a stronger attraction for electrons. So based on what we saw in the PowerPoint, sketch what the electron distribution and proton distribution should be after, and then fill in with words, explain why it happened. Include one of these terms. Was it induction, polarization, grounding, charging by friction, or charging by contact? Write out one of those terms, and then with a couple sentences explain what that means. Like, for example, if you think it's induction, then say induction because the electrons, and then you describe it out. Okay, so I'll pause the video, give you a chance to jot in the correct answer. Okay, we're on to step 2. Reading along, if you read, it says, the teacher brings the charged rod near the neutral pith ball. I'm not going to touch it. I'm just going to bring it near. So, let me charge it again because it was on the floor. Okay, so, oops, wasn't supposed to touch it, but you saw what happened. Okay, a little tricky. So you should see the pith ball moving toward the rod. Okay, So that was what you would observe. It says right under the diagram, record your observations below. So you write out that the pith ball was attracted to the rod, and then you explain why it happened. Again, you're including one of the following terms: induction, polarization, grounding, charging by friction, or charging by contact. Okay? And there's even a little diagram here to draw the molecular distribution or redistribution on the pith ball, which has no charge on it. This circular thing represents the rod negatively charged, brought next to the pith ball. Don't touch, but yet it attracts. So draw and explain. Okay, so we're going to move on to step 3. Step 3 says the teacher touches the rod to the pith ball. So that's what I'm going to do now. I'll charge it up again because I put it down, so it probably lost its charge. Okay, so it's going to attract and then touch, and then after it touches, notice what's happening to the pith balls from the rod. They used to be attracted. Now look at them, right? So it touches and then they're swinging apart. So you have to, let me just touch this. So then the next thing, record the observation below, right here, record what happened, and then explain why it happened. Again, using one of the terms. You include induction, polarization, grounding, charging by friction, or charging by contact. Don't just write what it is, explain what that means. Okay, so I'll pause the video here to give you a chance to fill in your observations and your hypothesis about what happened. Okay. Step 4. After touching both pith balls, the teacher removes the rubber rod. Okay, so first thing I want to say is right now, these are not attracted to each other. Pith balls never attract each other because if they were oppositely charged, they just neutralize each other. So the only reason why they're touching is because gravity swings that down into the other one, right? So that's why. So they're not attracted right now, okay? They're just hanging down with no repulsion. But now when I touch them both, we'll see what happens. Okay, so they repel the rod and then I remove the rod. Oops, not. Oh, paper. Yeah, sometimes these experiments are tricky. Let me try a different rod and see if it works better. All right, it's slightly working there. So what do you see? For a moment, it was the phenomenon that we're supposed to see. I guess I'll just tell you because it's not working that effectively, but basically they are repelling each other now. Okay, now it's working a little bit better. So they're repelling each other. Sketch that in. Okay, sketch that in the diagram right here. You could draw the pith balls spread apart like that and then record the observation. You would say that they're repelling each other and explain why they are repelling each other. You don't need a term here. You just need to explain why are they repelling each other in terms of charges and interactions. I'll pause the video and give you an opportunity to catch up. Okay, so let's continue on. The last one regarding the pith balls. Step 5. The teacher then touches both pith balls with his hand and then removes his hand. So you should see these things still repelling, okay? And now keep in mind, I'm much larger than those pith balls, right? I'm like thousands of times more massive than that. So here I come, a big source of charge. And right now I'm neutral, nothing charged me up. And I'm going to come and touch these both with my hand, and then I'm going to let them go. So the first thing is you're going to sketch what they look like right here, okay? You're going to record the observations. You're going to say in words what's happening to those two pith balls. And then last thing, you're going to explain why it happened. You're going to include one of these terms, only one. Include induction, polarization, grounding, charging by friction, or charging by contact. Put the term down and then explain with a couple sentences what that means. Okay, I'll pause the video to give you a chance to fill in your responses. Okay, so there's a few questions here. You can answer those, okay? And let's see, yeah, so answer those questions. I'll pause again to give you a chance to fill those answers in. Okay, so next we're done with the pith balls. We're going to move on to something called the electroscope. Electroscope, basically, what it does is it detects when charge is present. In most physics books or tests or diagrams, oops, let me turn this way. An electroscope is two pieces of metal that hang down from a metal ball and a shaft. And you see how they flop around because they're free to swing about. So that's what two pieces of metal hanging down. Those metal pieces are called vanes, V-A-N-E. A vane, a plural, you put an S on the end, vanes, okay? So what happens is if I bring charge next to this metal here, what can happen is I can force, if I put a negative charge near here, it repels the electrons down and makes the vanes spread apart because they're both negatively charged. When the vanes go back down, even if they end up touching each other, like some electroscopes, they end up touching, it's not because they attract. It's because the vanes are neutral. So either both vanes are both positive and the vanes spread apart, or they're both negative and they both spread apart. Or they're neutral and they hang down limp. Those are the possibilities. They are never oppositely charged and they attract. That never happens with an electroscope. Okay? So this is a little hard to see, and it's kind of a cheap electroscope that's not very effective. But it may work. Let's see if it works and if you could actually see it. Not too well. Maybe if I turned it a little bit. Yeah, there. You could see the vanes a little bit better. Maybe I'll even zoom in a little bit. All right. And I will bring a charged rod, and you should see that they spread apart, right? So you can see that. But it turns out that there's a better one that we have for demonstrations. It's built a little differently. Looks like this, and I may have to zoom back out. So. All right, so there it is. And let me move this because it kind of gets in the way. And the door seam is there, so that messes with it a little bit. There, so more on a blank wall. So this only has one vane. Oh, a little bent up too. Okay, so I didn't realize this got bent up. Let's see. Give it a little adjustment. There, okay. And the reason why this is more effective is because it's basically a very light vein. And this one vein is fixed, okay, but this one is free to swivel. And if you get it to be almost balanced, then it's very responsive, unlike the other one. And it's got a bigger vein so you could see it. But in all the diagrams for the rest of the experiment, I want you to draw two veins spreading out or going in, okay? So that's, you know, this will show us the phenomenon, but again, you're drawing two veins. So in part 2, number 1, it says the teacher charges up a rubber rod by rubbing it with fur. He then brings it near a neutral electroscope without touching it. So let's do that and see what happens. Well, we already saw it, but we'll see it with this one. Okay, and you see a nice dramatic, right? You see that needle spring out. Okay, so I'm not touching, I'm just bringing that rod near. And yet somehow the veins are still spreading out. So what you're going to do, oops, is, it wants to keep falling. Maybe my basement is haunted. Looks like the thing wants to roll away, no matter which way I put it. It's only a logical conclusion, right? There's a ghost messing with my experiment. Okay, so back to the physics, right? So what you're going to do here is sketch the veins on the bottom of the electroscope as well as the charge distributions of the electroscope. So I'll help you with this. What I want you to draw is a couple rectangles. Well, I'll show you. Maybe not. I don't know what I did with my pencil. Okay, here's another one. Okay, so you see that I drew the veins spread apart, and that allows me to draw minuses or positives wherever they need to be. So what I want you to do is draw minuses or positives wherever you think they belong in this electroscope. Okay, and then your observations below are that the veins spread apart. And then explain why it happened. Include induction, polarization, grounding, charging by friction, or charging by contact. One of those terms and explain why. Okay, so I'll pause the video to give you a chance to catch up. Okay, so we're on to step 2. The teacher then removes the charge rod. So I was supposed to be holding it there, but I was busy explaining things to you. But I was supposed to be holding it, keeping the veins apart. And then I'm going to move the rod away. So here it is. When the rod is near and never touched, right, the veins are spread apart. Now in part 2, I remove the rod. Okay. And so you want to sketch the veins, again, as blocks or rectangles. And you see they collapsed. But there are 2 of them, right? So you draw 2 of them hanging down. You record your observations. The veins came back down. And then explain why that happened. So no terms that you have to use. Just explain in words what happened to the electrons or protons. And I'll pause the video to give you a chance to catch up. Okay, let's move on to step number 3. Okay. Step 3, the teacher brings the rod back to the electroscope, touches it to the electroscope, then removes the rod. So now I'm going to actually touch the electroscope. Let me get it charged up again. Okay, let's see. Okay, and then I remove it, and you should see, not that great, but oh, removed all the charge this time. Well, I think that's the best I'm going to do today. But you should see after I touch it, the veins are still slightly apart and the rod is gone. Okay, so that's what you're going to record the observations. You're going to draw the two veins spread out again, right, like this. And you're going to explain why it happened. This time you have to use a term again. Include induction, polarization, grounding, charging by friction, or charging by contact. Again, I'll pause the video and give you a chance to jot down your results. Okay, so step 4 we're going to skip because it's very temperamental. We don't need to worry about that. But looks like I lost a little bit of my charge here, so let me try and charge it up again. Try the other one. Yeah, not getting good charge transfer today. There we go. That's better. Okay, so this is, where we left off with step 3. Now we're on to step 5. The teacher then touches the electroscope with his hand and releases it. So here I go, touched it, let it go. Okay? So you're going to explain what happened. You're going to sketch the veins, right? So you could see, obviously they're hanging down limp. You're going to sketch 2 veins. You're going to record that they're both hanging down. And you're going to explain, but you're going to use a term again. Include induction, polarization, grounding, charging by friction, or charging by contact. One of those terms, write it down, and then explain with a couple sentences. I'll pause the video, give you a chance to catch up. Okay, so the next one, the final one we're going to do here. The teacher can only charge a metal plate by placing it on a charged plastic, then touching the plate with his finger, then removing his finger, then removing the plate. If any step is left out, the plate will not acquire a charge. So let me show you what I mean by that. So I've got a plastic plate over here. Another metal plate with a plastic handle. And what I'm going to do is I'm going to charge this up by rubbing it with the fur. Nice and charged up. All right, now I put this on here and let me take it off and go near the electroscope. Nothing. Now watch this. Listen carefully too. Hear that little zap? I take my finger off. Look at that. And if I touch it, you could even hear a spark. Okay? Lots of charge transferred there. So, again, let me show you. Now, in theory, I don't need to recharge this plastic up, but over the years, I find that it loses a little bit. But in theory, it doesn't lose any charge in this process. So, again, listen. You hear that spark? Now I remove my finger and I bring it near, and it made the electroscope spread apart. Now let me touch it to the table to neutral. Ooh, that was a nice spark, right? Let me do it again. Touch, release, bring it near, and the vein spreads apart. But, ooh, that was another good spark. Let me show you a little subtlety. Okay, touch my finger. I won't let it go. I bring it up like this, and now, nothing. Okay? Leave my finger intact. Now release it. Nothing. I must touch and release while it's on the plate, the plastic, the charged plastic. And only then does it work? Okay. One year, I had a student, when I said, explain what happened, he called it electromagic. Maybe it's a little bit of magic, right? But there is a term. So you need to pick one of those terms. And you also need to draw pluses and or minuses on this plate to indicate what happened, and on my finger. So, and then with words, explain why it happened. Include induction, polarization, grounding, charging by friction, or charging by contact. Pick one of those terms and then explain a little bit about it with a couple sentences. I'll pause and let you catch up. Okay, so that was the electrostatic charge experiment. Remember, as I said before the PowerPoint, where do you get charge? Everywhere, okay? Everything you touch, everything you eat, everything you smell, the air you breathe, it's all made of charges. Protons and electrons. Then there's neutrons there too, but they don't contribute to the charging situation. The way you get charge is by disturbing the balance, where normally every object is an equal number of protons and electrons, 1,000,000. You can either add electrons to something to make it negative, or strip some off to make something positive. You never add protons to a solid object to make it positive. You might have 1,000 electrons and 1,000 protons. If you pull off 100 electrons, now you have only 900 electrons and still the same number of 1,000 protons. So there's an extra 100 protons without a partner. That's how you make something positive. Because when you touch something, you're touching the electrons. So if I'm stripping away charge, I can't reach into the nucleus of the atom and pull the protons out unless I want to make a nuclear reaction like a nuclear bomb or something, right? But if I'm just touching, I'm not making a nuclear bomb, right? I am stripping electrons off or putting them on, making it negative, stripping them off, leaving the thing positive. So that's the heart of what we saw today. I hope you enjoyed the demonstrations, and I'll see you in the next physics video.